Quadratic functions and models. A quadratic function is a polynomial function of degree 2. This means that a quadratic function has the form f of x equals a times x squared plus b times x plus c. And the number a in front of x squared cannot be 0. And the reason for this is because if a is 0, then you would just have a linear function. The standard form of a quadratic function is f of x equals a times the quantity x minus h squared plus k. And the standard form is a more useful form than the original here. And this is because when a quadratic function is in standard form, we know that the graph is a parabola with a vertex at the point hk. We also know that if a is positive, the parabola opens upward, and if a is negative, the parabola opens downward. So the first thing we need to discuss is how do we change a quadratic function from this original format into standard form. So here we have a quadratic function, f of x equals 2x squared minus 12x plus 13. And first we want to express it in standard form. So this process involves completing the square. So let's go ahead and go through this. The first thing I'm going to do is I'm going to factor out the number in front of x squared, but I'm only going to factor it out of the first two terms. So when I factor the 2 out of there, we're going to have x squared minus 6x. Now let's leave a space. And the positive 13 we're going to put on the outside of the parentheses. And this is why nothing changes with the 13 here, because it's not affected by the 2 outside of the parentheses here. Next, we're going to complete the square. So we're going to take half of 6, and we're going to square that. And that's 3 squared, which is 9. And that's the number we're going to add here. And then to compensate for this positive 9 here, we have to recognize that 9 is multiplied by 2. 2 times 9 is 18. So we need to subtract 18 over here to compensate for the 9 that we added. Next, we'll go ahead and simplify. So we'll do a little factoring here. This is going to become x minus 3 quantity squared. And then positive 13 minus 18 is negative 5. And you see now we have the quadratic function in standard form. So for part B, find the vertex. So to get the vertex, we just need to look at the coordinate here and here. Now let's keep in mind that the standard form is 2 times x minus h squared plus k. So what this means is that whatever number you're looking at here, this is the opposite of h. So that means h is positive 3. So the vertex has an x-coordinate of positive 3. And the value that you see here is the value of k, and that is negative 5. So the vertex is the point 3, negative 5. Also here, we want to find the x and the y intercepts. Let's go ahead and get the y-intercept first. That's a little bit simpler. To do this, we're just going to let x equal 0. So f of 0 is going to be 2 times 0 minus 3 squared minus 5. This is 2 times 9 minus 5, which is 13. Now, I should note that it's probably a little bit easier to just plug 0 into the original, because you can see if you plug in 0 for x, these are going to go away, and you're just going to get positive 13, a little bit faster. Now, to get the x-intercepts, we need to remember that to get the x-intercepts, we let y equal 0. Now, again, I think I'm going to go back to the original equation here. If I let y equal 0, we're going to have 0 equals 2x squared minus 12x plus 13. Now, you can solve this equation however you like. You can try factoring. In this case, this is not factorable, so we're just going to go ahead and use the quadratic formula, which is going to be negative 12 plus or minus the square root of negative 12 squared minus 4 times 2 times 13, all divided by 2 times 2. This is going to be positive 12 plus or minus the square root of 144. And then here we have 4 times 2, which is 8, and 8 times 13, which is 104. So that's minus 104, and then all divided by 4. This is 12 plus or minus the square root of 40 divided by 4. We can do a little simplification here. The square root of 40 is the same as 2 radical 10. And finally, if we divide everything by 2 there, we get 6 plus or minus the square root of 10 divided by 2. Now, we would approximate these so that we can sketch the graph here in just a second. So let's bring in these approximate values. And so when we do the positive, we get 4.58, and when we do the negative, we get 1.42. So these are our approximate x-intercepts. And now in part C, we want to sketch the graph of f. So to get a graph of a parabola, you really only need the vertex and the intercepts. And really, you only need the vertex and the x-intercepts. So the vertex is at the point 3, negative 5, which is right down here. And then one x-intercept is 4.58, which is right about there. And the other one is 1.42, which is here. And then we can simply sketch a graph of this parabola. And finally, it says find the domain and range. Well, the domain is all real numbers. The domain of any quadratic function is always all real numbers. However, the range is going to be the y values that you get on this graph. And you can see the lowest y value is negative 5, and you get everything above negative 5. So the range is going to be negative 5 to infinity. So as you can see, for any quadratic function that you graph, you're going to get a parabola. The vertex of that parabola is always going to either be your minimum value or your maximum value. And what determines this is whether the parabola opens up or opens down. So if the parabola opens up, the vertex is going to be the minimum value. If the parabola opens down, the vertex is going to be the maximum value. So in our next example, it says, consider the following quadratic function, express it in standard form, sketch the graph, and find the minimum value of f. And we know it's going to be a minimum value because since we have positive 5 in front of x squared, we know this parabola opens up, therefore the vertex is going to be the minimum value. So first we have to express it in standard form. So we have f of x is equal to, I'm going to factor the 5 out of the first two terms, just like we did before. And then now we're going to take half of this number and we're going to square it, and that gives us 9. So we're going to add 9 once again. And 5 times 9 is 45, so I need to subtract 45 to cancel that. And so in standard form, we can write this as 5 times x minus 3 quantity squared plus 4. So now we know the vertex is going to be the point 3, 4. So for the second part, to sketch the graph, let's go ahead and sketch the vertex, which is at the point 3, 4, which is right here. But we have a little bit of a problem. This parabola we know opens up. It does not open down. So if it opens up, you're going to notice that there is no x-intercept here. So let's not waste our time trying to find an x-intercept that doesn't exist. So in this case, to sketch the graph, all I'm going to do is plug in x equals 2 and x equals 4 into our function. So f of 2 is going to be 5 times 2 squared minus 30 times 2 plus 49. And this is going to be 5 times 4, which is 20, minus 30 times 2 is 60, and then plus 49. This is going to be 9. So f of 2 is equal to 9. We'll go ahead and graph that point. And because of symmetry, we know that f of 4 is also going to be 9. Now, if you want to pause this and verify that, you can do that. But we know that the graph must look something like this. And finally, what is the minimum value of f? The minimum value of f is the lowest y value. And so the minimum value is 4. So in this next example, we have another quadratic function, and we want to do the same thing. Express it in standard form, sketch the graph, and in this case, we're going to find the maximum value, because since we have a negative in front of x squared, this parabola is going to open down, and when it opens down, the vertex will be the highest point on the parabola. So first things first, in part A here, we need to express this in standard form. So what I'm going to do is I'm going to factor out the -1 that is right here. So we're going to have -1, and I'm only taking that out of the first two terms. So when you pull -1 out of here, this becomes -x, and then the +2 we're going to leave on the outside here. Next, we're going to take the middle number, which is equal to 1. We're going to divide it by 2, and we're going to square that. And this, of course, is equal to 1/4. So we're going to add 1/4 here. And then we have to compensate for that out here. But this 1/4 gets multiplied by -1. So -1 times 1/4 is -1/4. So we need to add 1/4 to the outside to compensate for that. So now this is going to be -1 times x minus 1/2 quantity squared plus 2 1/4, which is the same as 9/4. So this is the equation of our quadratic function here in standard form. Next, we want to go ahead and sketch the graph. So let's go ahead and recognize that the vertex of this parabola occurs at +1/2, +9/4. So +1/2, +9/4 is going to be right about there. So remember, 9/4 is just 2 1/4. Now, to graph this, we can do the same thing we did in the last problem, which is we could just plug in an x value, say x equals 0 or x equals 1, or you could find the x-intercepts. I think in this case, I'm just going to plug in 0. So f of 0, and I'll use the original here. Right? Here's the original equation. If I plug 0 into there, we are very clearly going to get 2. So f of 0 is equal to 2, which is right here, and f of 1 is also equal to 2. Now, if you zoom in on this, this is not really a great picture, right? Because these points are really close together. So in this case, I might plug in a couple of additional points. Let me plug in x equals 2 and x equals -1. So f of 2, if we plug that into the original, we're going to have -2 squared plus 2 plus 2. This is going to be -4 plus 4, which is equal to 0. So when I plug in 2, we get 0, and that also means when we plug in -1, we're going to get 0 as well. And now we can sketch the graph a little more confidently. And for part C, what is the maximum value of the function? The maximum value is the highest point on the curve. And that highest point corresponds to 2 1/4, which we're going to write as 9/4. So that is the maximum value of the function. Next, we're going to discuss a formula for finding the maximum or minimum value of a quadratic function. So when we have a quadratic function, instead of putting it in standard form, which involves completing the square, we can find the vertex of the parabola by using the formula x equals -b over 2a, and then the y value will just be the function value of -b over 2a. Let's go ahead and take a look at an example. So for part A here, we want to find the maximum or minimum value of the quadratic function f of x equals 1x squared plus 4x plus 0. So notice that a is 1, b is 4, and c is 0. So to find the vertex here, we're going to use the formula x equals negative b divided by 2a. Plug in the values of b and a into this. We get negative 4 divided by 2 times 1. And this is negative 4 divided by 2, which is negative 2. Notice that c is not used in the formula for finding the x-coordinate of the vertex. I just wrote it down just to remind you that these numbers are a, b, and c. Now to get the y-coordinate of the vertex, we're simply going to plug negative 2 into the function. So we're going to do f of negative 2. And f of negative 2 is going to be negative 2 quantity squared plus 4 times negative 2. This is 4 minus 8, which is negative 4. So the vertex is the point negative 2, negative 4. Now the question is this a max or is this a min? So to answer that, you have to remember that the 1x squared means that this parabola opens up. And if a parabola opens up, the vertex is going to be the minimum. So for part B, we're going to do the same thing. To find the vertex of this parabola, we use the formula x equals negative b divided by 2a. Let's keep in mind that b is 4 and a is negative 2. So this will be negative 4 divided by 2 times negative 2, which is negative 4 divided by negative 4, which is 1. And then the y-coordinate will just be g of 1. And this will be negative 2 times 1 squared plus 4 times 1 minus 5. And if you do the math here, you get negative 2 plus 4 minus 5, which is equal to negative 3. So the vertex in this case is the point x equals 1, y equals negative 3. And again, is this a max or a min? Well, in this case, we have a negative number in front of x squared. This means the parabola opens down, and therefore the vertex must be the highest point, which is a maximum. In the next example, we have a quadratic function that models gas mileage for a car at a given speed. So S is the speed at which the car is being driven, and M of S is the gas mileage at that particular speed. The question here is, what is the car's best gas mileage? Let's keep in mind that this graph would be a parabola opening downward because we do have a negative number in front of our squared variable. And that means the vertex is going to represent the highest value of M. And that will be the car's best gas mileage, right? Because the best gas mileage means the highest gas mileage. So to make a long story short here, we need to find the vertex of this parabola. And we know the formula says x equals negative b divided by 2a. But in this case, we don't have x, we have s. So let's go ahead and change this to an s. And now let's just plug in b and a. So let's recognize that a is negative 1 over 28 and b is positive 3. So when we plug this in, we get negative 3 divided by 2 times negative 1 over 28. These negatives are going to cancel out, and we're going to end up with 3 divided by 1/14. So keep in mind the 2 goes into 28 there 14 times. And this becomes 3 times 14, which is equal to 42. So we're going to get the best gas mileage at a speed of 42 miles per hour. But it's asking for what is the best gas mileage and what speed is it attained. So we've got the speed part, but we need the mileage part. So to find the mileage at the speed of 42, we just need to plug 42 into our function. So we get negative 1 over 28 times 42 squared plus 3 times 42 minus 31. And you might need to use a calculator to do some of these calculations, but 42 squared is 1,764. So negative 1 over 28 times 1,764 plus 3 times 42 is 126, and then minus 31. Continuing here, we have 1,764. We're going to multiply that by negative 1 over 28. And when you do that, you're going to get negative 63 plus 126 minus 32. Now we can just add these up. So negative 63 plus 126 minus 32 is 31. Okay? So the best gas mileage is going to be 31 miles per gallon at a speed of 42 miles per hour. In our final example, we want to maximize revenue from ticket sales. It says a hockey team plays in an arena that has a seating capacity of 15,000. With the ticket price at $14, the average attendance has been 9,500. A market survey indicates that for each dollar the ticket price is lowered, the average attendance increases by 1,000. So cheaper tickets means more people will buy tickets. So in the first part, we want to find a function that models the revenue in terms of the ticket price. So let's go ahead and say the ticket price is X, right? We don't know what it's going to be, but let's assume that it's equal to X. Now the revenue generated is going to be the ticket price X multiplied by the number of tickets. So the question is, if you charge X dollars, how many tickets do you expect to sell? Well, we currently sell 9,500 tickets when we charge $14. So if we charge less for the tickets, we're going to get an increase of 1,000 for every dollar less that we charge for the ticket. So the attendance is going to be 9,500 plus 1,000 multiplied by the number of dollars less than 14. So if you're charging X for the ticket, we're going to do 14 minus X to figure out how many dollars less than 14 you are charging, right? So for example, if X is $12, then you are charging 14 minus 12, which is $2 less, and therefore you can expect 2 times 1,000 more ticket sales. So the number of tickets is this quantity. So now if we plug this in, we're going to have X multiplied by 9,500 plus 1,000 times 14 minus X. And now we're just going to simplify this. This is X multiplied by 9,500 plus 1,000 times 14 is 14,000. So that's going to be 23,500. And then we have 1,000 times negative X. That's negative 1,000X. And if we multiply out the X here now, we get negative 1,000X squared plus 23,500 times X. And so this is our revenue function. And I think that this is probably the hardest part of the problem. Now for part B, find the price that maximizes revenue. So we want to find the vertex of this parabola because this is a parabola that opens downward. So the vertex is going to represent the highest point, which is going to be the highest revenue. So we know that X is equal to negative B divided by 2 times A. This is going to be negative 23,500 divided by 2 times negative 1,000. This is 23,500 divided by 2,000. And if you do the math on that, you get 11.75. So the ticket price that is going to generate the highest revenue is $11.75 per ticket. For the last part, it says, what ticket price is so high that no one attends and so no revenue is generated? So to figure this out, we're just going to set R equal to 0, because if there's no revenue, that means revenue is 0. So if we take R, which is this function here, and set it equal to 0, we get negative 1,000 x squared plus 23,500 times x equals 0. I can solve this by factoring out a negative x, and if I do that, I get 1,000x minus 23,500. And clearly one way this is going to be 0 is if x itself is equal to 0. And so that should make sense. If you charge $0 for the tickets, you're going to get 0 revenue. But also if I set this one equal to 0, I'm going to get x equals 23,500 divided by 1,000. And this is 23.5, which translates to $23.50. If you charge this much for tickets, nobody will attend the game and you will make no revenue. And that concludes this video lesson.